We are going to find all local maxima, local minima, and zeta points for this given function f of xy equals 3x squared minus 2xy plus y squared minus 16x plus 4y plus 14. And we are going to use the d-test. First, find the critical point by finding the first partial derivative with respect to x equals 0, partial derivative with respect to y equals 0, and then solve for the solution x and y, and we name it as the point AB. Partial derivative with respect to x is 6x minus 2y minus 16. Partial derivative with respect to y is negative 2x plus 2y plus 4. And when we let it be 0, we get the system of two variables. I'm going to write it in this form. So 6x minus 2y equals 16. Negative 2x plus 2y equals negative 4. Solve it simultaneously. If we are going to get rid of the y, we're going to add these two together. Negative 2y cancel out to get 4x equals 12. Therefore, x equals 3. Now we get x equals 3. We're going to look for the y value that satisfies both equations. I'm going to pick the second one. So negative 2 times x, which is 3, plus 2y equals negative 4. We got 2y equals negative 4 plus 6, which is positive 2. Therefore, y equals 1. We got the critical point 3, 1. So the next step, we are going to find the quantity d, which is from the second partial derivative with respect to x multiplied by the second partial derivative with respect to y minus the second partial derivative with respect to x with respect to y squared. Evaluate at AB. In this case, the AB is 3, 1. So based on the first partial derivative that we derived, we're gonna continue from that point. That means the second partial derivative with respect to x is 6. The second derivative with respect to y is 2. And the second partial derivative with respect to x with respect to y is gonna be negative 2. All right, keep in mind the second partial with respect to x is 6, which is positive number. Now, bring the values to the formula to find the d. Fxx, which is 6, multiplied by Fyy, which is 2, and then minus Fxy, which is negative 2, quantity squared. We will get 12 minus 4, or the value 8. In this problem, the d is positive, and the fxx, or the second partial derivative with respect to x equals 6, is positive. Positive concave up, so we're gonna get the local minimum at 3, 1. Since we have one critical point, so we just have one local minimum and no local maximum and no saddle point. Next, we're going to compute the value for the function at 3, 1 is 3 times 3 squared minus 2 times 3 times 1 minus plus 1 squared minus 16 times 3 plus 4 times 1 and then plus 14. The result is negative 8. Therefore, the point 3, 1, negative 8 is a local minimum point on the plane for this function.